tutorial. So this tutorial is object as service, so streamlining cloud native application development for the cloud continuum. So let's start with introduce ourselves. So hi, just call me Viz. So my full name is Professor Nalabujikon. So I am a PhD graduated. I work right now in Toyota as a data scientist, but I was do a lot of work on this project and then HPCC lab. So nice to meet you. So
My previous PhD student, he recently graduated.
yeah. So can you two introduce yourself?
I'm Tapochit Chandropal. I'm a PhD student at the HPCC lab as well. And so I also worked on this project when we was graduating at the end. So I'm on my second year, and yeah, that's it.
Okay. So for this tutorial, the agenda gonna be like we start do a bit of introduction, like what we talk about, and then we're gonna show you a bit of the demo, like okay, what we have here, and do the deep dive, and then the IPDPS request are to have a 30-minute coffee break, and then we can come back and then having the go through the project and tech stack and do a bit of hand-on, then finally followed by the conclusion. Um, so it is it should be like so okay. So I'm not sure like how much you know about the serverless paradigm, but this is quite old already. But I want to talk about it anyway. So like kind of like decade ago, we have like something like in-house server. So we just buy the server and have it in the house. And then we have a cloud. We start is as an infrastructure as a service. So we build everything as a VM. So basically, as a developer, we can just get the VM from the cloud like anytime, anywhere. So, but that is like a bit of work because VM, we still need to set up the OS. So ideally in the business wise, you want to just have a deployed application. So you don't want to build everything. So we have the new abstraction called platform as a service, right? And lastly, people just realize that we don't need the whole platform and the whole application just to do the application. So we just have a single function to run and then have a platform to build and scale and deploy and everything that we call as serverless. So the name of the serverless is pretty much straightforward. That means that you work with it as you don't have a server being managed by the cloud. So this is the promise of the serverless. Like so, basically, ideally, we don't want to manage anything. We just have everything being managed by the cloud. So the benefit of it is we don't need to predict like how much uh, the sizing that the business gonna use. We just let the cloud scale it, so we don't need to pay for the opportunity cost and don't lose the customer by degrading of the service. So, but the reality of the service is quite not meet the expectation. In the cloud right now, we have like so many cloud services. So to build the real application right now, like there is a bit of like learning curve. So you need to study each services, and then we need to understand like how to combine them together. So, and then integrate each of them is quite tough as well. Like, you need to understand like how the each services API is, and then combine them. And also there is a performance limitation because they try to build a serverless as the on-demand use. So you don't have the real ability to control the performance of the serverless. So it can be like slow when you don't have any user. It just scale down and then it's just slow. So the technical root cause is, as I mentioned, the state is really fragmented. So if you have like multiple function, since the function it cannot be able to share the state, so we need to staging the data as for each function, and then put the state as the storage. So and then the logic of the workflow is spread across the orchestration because the application is not about the code where it's being run, but it's also like for the state and for like many multiple things. So we need to build like functions, database, and orchestration. So yeah, so this is what we're talking about, and the cause is when we have a separate abstraction, the performance is go really bad because we don't we limited how much we can do on separated abstraction. So since this is a tutorial, so I don't want to like push all the technical dump. So we can go like quick. So and then if we have a QoS and constraint, it's not like straightforward because we usually have a objective, and then we need to guessing like what is the best configuration to meet that objective. So so basically in the end, like you're gonna do it as a multiple round. So you guess one configuration and try it, and it doesn't work, you need to try it again. So, and the complexity is go really deep in when we want to deploy the application in the edge cloud. So you can imagine that in the edge cloud, like the reason that we want to deploy onto the edge is we have the service that is latency sensitive, and then some service that not latency sensitive, we can just deploy it on the cloud. So this is go to the edge. So, and now like the system get really complicated. So we need to share the state across edge and cloud and share like the workflow across edge and cloud as well. So usually we need to have like some kind of like service fabric between edge and the device. So and so like alternatively we can like deploy everything on the cloud, but that is like not working well as I mentioned. So and when we deploy on the edge, it get really complicated. And you can see like we need a lot of personnel to take care of each element. And the state management is not straightforward anymore because you have a two version of the state and you need to keep them sync and consistent. So what happens like if the channel that between cloud and edge is not being partitioned or like being disconnected, you have an in-sync state and then gonna lead to the uh, invalid state of the application and cause a lot of problem. So like all of this, like it's just a interconnect problem. Like how to, and then we come up with the proposed solution that is a OS. So the first is like how to unify like state, resource, and workflow abstraction together. So then become it as a OS. And then like how to be able to build that non-functional requirement. So it's something like SLO objective that we have a single unified platform that be able to like okay you just mention this is what the list amount of the service that you want and then it just give it to you and lastly like how to coordination between like edge and cloud together so that like build the latest version of OS that we call as OaaS-IoT, or there is alternative name that we use to present in this conference that called 8Weaver. So if you want to learn more about this, you can meet us in the Friday afternoon. I'm not sure about the time exactly. It should be 1 p.m. or something. So the idea is really like really straightforward. So we want to build like this is the top part is the fast version. So you can imagine that in the real application you need to have like logic, state, and communication fabric, like connect them together. That is like a lot of work. And then for the 8Weaver, we want to build the abstraction so that we can just declare and then the connecting them together is just like the part of the abstraction. So you don't need to work on it. So, so the workflow gonna look like this. So you write the code and write the class definition. So you can imagine some kind of like configuration file, and then you build the code into the container image, and then deploy it as a class runtime. So you can see that analogy is come from the object-oriented programming, which is pretty much like the same. So and then you just use it by the system. So yes, so I guess we can show a little bit of the demo. So before I, I think this one.
You should scan this, right?
Yeah. This gonna show the dashboard, right?
Yeah, audience. Oh, yeah, this one is dashboard. Audience dashboard.
Okay. Let me recheck. Okay. So in this okay, let me hide this real quick. So in this example, what you're gonna see is you see like one canvas. So you see this part. It basically like empty canvas, and then you can draw anything. And then on my side, I'm gonna show the presenter canvas. So this tutorial is really simple. It shows the synchronization between the edge and cloud. So you can imagine that, oh, okay, when you open the dashboard, it have a one piece of the canvas, but I'm going to show you the whole canvas combined together, and that you can represent it as a cloud. So you can imagine that each piece of the pixel canvas is representing the edge device state. So and then
Essentially, our phones are are edge.
yes,
And all of the like it will have, let's say, 16 into 16 pixels, and all of the pixels or all of the partitions are assigned to an audience. Okay. And all of them I'm gonna draw, and it's going to be like it's going to be accumulated together into the presenter one, which is the cloud. This and all of the audiences are the edge. Edge. Yeah.
yes. So I will show you the code really soon, but I want to explain like how okay, let's show how the real thing works real quick, because that could be keep the full picture. So right now, when you see it, so if you are audience, you can draw anything, and it will pop up here. So I believe that the link is gonna give you the same URL on the grid. So it's gonna be like the first image. So you can change the grid into like anywhere else. So you can change it like to from 00 to 0, like, let's say 01. You're gonna get your own grid. And then when you draw anything,
Partition it in like two,
huh?
like one on the side.
Oh, yeah. I can do that. So let's say this one is the first one, right? Okay, it's a little bit slow. Let's say the third one is third. Oh, it's here. Oh, okay. So it's X and Y. So when I put the 03, it is like X and Y. So it's gonna show here. And then if I draw it from the presenter side, the state is syncs both way. So it's not just like one way. So and then basically you can see that the synchronization is done. And what I want to show now is um
Did get what are we watching? What does that mean? This pixels.
so it's an example application that
Okay.
we want to deploy on this framework, and I'm going to like show you how it works first, and then explain like what is happening behind the scene.
So essentially, it wants to show the consistency across edge and cloud. So when you
What
put
is on the edge? So
Huh?
the pixel, what we draw now, it
you
represents
take
one
a
edge
rule
now.
of edge.
It's a one edge now.
Yes, one edge. Like if I connect and you connect, we are two edges, and then we all get aggregated there as the cloud. Is that right?
It's to demonstrate communication.
Demonstrate communication
Nothing
and
to do with-
consistency.
Nothing to do with funding and service. It's
Uh,
just communication.
Yeah, it's
Oh,
a consistency across the different tiers, the edge cloud.
Yeah. So like when you paint something, it make the function call into the edge server. So an edge server and a cloud have some synchronization mechanism. So and then it broadcast the state change as a WebSocket. So you can see that it happen like both way. So if I draw something on the cloud, it's going to send the pen event and synchronization and broadcast the event as the WebSocket onto the client side as well. So and then here in this I have one question for you. So do you know the game of Life? Okay, so the game of Life is basically like a kind of like a small game that have a rule that is like if you have a pixel on the screen, you can see that if you have like more than 3 pixels, it is overpopulated, it going to die. So that pixel gonna gone. And if you have a pixel less than two, is have like two little pixel is gonna die again. But if you have exactly 3 pixel nearby, so it can like spawn. So I can show you the example here. So when I click this button, it run that logic of the game of life, and then you can see that it apply the state of them. So and then when click again, so it apply the one step of the game of life. So what happened is is run that logic. So this what is this represent? So it is represent that we can run the logic on the cloud that aggregate all of the device together. While you have like a single uh, state of the device that you can keep applying, like keep drawing. But when we want to aggregate the state and then do the processing, it apply to the cloud and also sync it back to the edge.
So let's say now I'm writing M in the first entry, and then if you write something, will it be in the second entry or what?
Yeah.
Can you write
I
something?
tried it, especially in that corner. I see that the concepts now. Basically, each
Oh.
one have this opened.
Hmm.
Basically, there's one region there, whatever I draw, you do some kind of communication.
Right.
You have this appear there. Is that the concept? Okay.
Yeah, I'm drawing on the,
Yes.
drawing on
Now-
this one.
Yeah, it's the same. I can do this in here basically.
Right.
Right.
So this application is deployed using OAS, like our framework. So all of these are kind of objects, and we have a class, and like using that class, we are deploying this like let's say 16 objects here, and we are like this is the edge, and this is the edge, and this is the cloud, and all of these are like synchronized together.
Oh yeah. So so the good thing about this when we have like everything as a framework, we can do like something like more fancy that like let's say that okay, in the real world application, so we want to assume that okay, let me explain this first. So in the real application, so we want to assume that like the network disconnection is always happen, like it's happen all the time, but we need to build the application to relate it. So but to test it, it's kind of like getting difficult. So you may have like theory, you may have like implementation that assume that it can tolerate the network partition, but you don't know like how well it is can be done. So in this system, we have built up the some kind of the network emulator. So the idea is so the problem right now is I don't have uh there is some kind of like a system set up that misconfiguration. So I need to show you from my local. So it sorry that it's not gonna work on your side, but here what you're gonna see. So this is gonna be the OS dashboard, and then we're gonna show you like how it work like afterward. But in this one, we're gonna have a debug console, and then you can click to the partition. So also right now it not clicks it, and I can show you that this one is still working. Okay, let me figure out how to make it work.
Now this screen on the left side is the cloud dashboard.
I think
Yeah,
so.
yeah.
Yeah.
So it means what I see on my side should appear there.
Right now, is two of this deploy on local because right now the cloud system is not config with the network partition setup because the network partition is come with the performance.
He was asking that he was like, we gave the link, right? Can you go to
No,
the
it's
dev
just-
presenter link?
Oh, yep.
That's, yeah.
it should be there. I mean,
Which
yeah,
one?
Now it's there. Okay, now so
that was like another link,
Another
another
one.
instance.
Okay.
Yeah, yeah. That was a local like deployment. This one is the
Yeah, yeah.
one that is deployed in the cloud.
Oh, yes. So now I want to show the version that deploy on the cloud. So right now it deploy with the strong consistency. So the idea is if we run it, uh, we do the partition on the across edge and cloud. So this is a like really useful tool that we can test it that what happened if the network partition happen. So we can see that okay when we door on both sides, like nothing gonna happen, and then yeah, and then we can see like it still somehow like keep the state locally, and then we can heal it back, and it should keep sync it back. Let me. Yeah, I think I need to reload. That is weird. Okay. Do I use a collect port? 82. Hmm. Oh, yeah, yeah. I think it not keep syncing it back, but right now it the synchronization like happen again.
So
So
once you reconnect it, they can sync back again.
yeah.
Okay. But if you disconnect and reconnect, it won't go to the previous state.
It
doesn't
should be,
reflect yeah.
but I think I think this is like kind of get really deep detail. So to sync the state, there is a multiple mechanism to sync the state. So the idea is if you want to have like highly available, so you want to have a state being asset even though it not syncing, and then in the end like you want them to sync it back together. So that is like trade-off between the consistency and availability. So in this case, like I think it disable that. So it basically like keep consistency first and then availability like later. So when you draw is something, it's not going to apply uh until it come back.
Now it's on strong consistency and which form of
I think I need to recheck if it's strong consistency.
so essentially you can declaratively set the consistency level that you want between your edge and cloud.
Yes.
So you can put it on weak consistency or strong consistency.
Oh yeah, this one is strong consistency. So it's not gonna sync back because when it sync back, it's not the same. But it's not the same. I'm not sure what happened. But okay, let keep the thing going. So yeah, so this is the tools that we have to simulate the network partition. And so the workflow gonna look like this. So as a developer, we develop the code. So there is a multiple way to write the code because in the end of the day, it's going to deploy it as a either WebAssembly or either the container image. So there's multiple way to deploy it. But in this tutorial, we want to focus on the TypeScript because the TypeScript is really close to the that be able to deploy with the as a WebAssembly. And then we're gonna use OaaS-COI and run dev server as I showed it before that we can run locally. But in this case, like I don't want you to like, install anything. So we're gonna give you the URL and that you can test it on our cloud side. And then you just deploy it as a WebAssembly and push it to the cluster. So now everything is just like deployed across edge and cloud. So I think I think this is supposed to be script. Okay. So based on our previous plan, I think we go like really quick. we supposed to like have a coffee break, but I think because like we not have much people, we can continue with it. So the idea is like I think this part's supposed to be script. So the architecture of this OS is basically like we have a developer that we write the uh send the packet to the package manager, and then everything become deploy as the class runtime. So I think this is supposed to be skip. Yeah. So the, so we can see like we deploy both on the edge and cloud. So now like we
The Zoom thing from the
oh yep. So we write the code as the class based, like based on the object oriented programming. So now and then each class can be consumed another different class. So behind the scene, it's going to call some kind of like RPC, a remote procedure call, and like it just behave as they are like in the same machine as it is, but it's just a network abstraction behind the scene. So, and then you can deploy the SLA to like declare that it is the strong consistency or weak consistency, and locality, like it could be the edge or it could be cloud. So basically idea is you write the code and then you write at a class and that should work on your machine. And then when you want to deploy it, you deploy it with a configuration file that declare like what is the consistency or locality that you want, and the system will figure out like where it should be deployed.
So essentially, you want to develop one,
Oh, sorry.
if you can go back, you want to develop one IoT cloud-based application, and then you have some latency sensitive functions on the left side, and then on top of it, you have some latency tolerant. So the latency tolerant one wants to go to cloud, and the latency sensitive one wants to stay on the edge. Is that right?
Yes.
And then can you explain a little bit on this side, the class first? Like here, the device class and IoT class and SLAs?
Yeah. So basically, the
And
idea
then
is
explain on the board so that others can also sync with you.
yes. So basically the idea is we have the we drop the code, the application based on the class logic. Like we build a class that it should be self-contained as its own, and in its function. So let's say that we have a IoT class, service class that's supposed to consume the device class. So when you have this feedback function, and then the feedback function want to use the action on the device class, it basically just do the remote procedure call. So normally if two of these class stay together in your machine, it just like do normal function call, right? But when now it's distributed across edge and cloud, so when you want to call the class, and it behave the same as it in the single machine, but in reality it's not. It's separated, so it need to have like some kind of like hidden RPC call. So that is the magic behind the scene that uh the class should behave as it is. So in the architecture, you can see like we gonna have why not sure. Okay,
Maybe you can use that pointer.
pointer.
There's no pointer.
Oh, I think I can use the let's
Yeah,
say
yeah,
pointer
yeah.
here. Um, So I don't want to overwhelm you with this architecture because it's really complicated. But we want to focus on two parts. So will have like one control plane that called package manager, that is basically like get the package that is your deployment and your configuration into the package. And then we will have a cloud. It could be one cloud, it could be multiple cloud, because in the end of the day, like cloud and edge is just a machine, right? So we will have like multiple environment, and each environment gonna connect together with the networking infrastructure that basically like abstract the communication on is the system. And then you can connect the device agent. Basically, like you are the service, the machine that consume your services. It just plug it into the messaging infrastructure, and then you just the code that you deploy is going to be like class runtime. So yeah,
But the device agent is also part of OaaS-IoT, or it's just
the device agent is your the device that consume OS service, like the application, your application. Like in this case, like device agent is your browser, right? And then we deploy the system on the cloud.
for OaaS-IoT, we do not need any OaaS application on the IoT tier. It's only on the edge and on the cloud.
Yes, yes. So this is just a zooming level, but I don't want to overwhelm you, so we can just skip this. Yeah. So this is the, I think you want to take care. Oh yeah, you want to continue. So here in the control pane, we will have like packet manager that and the class runtime manager that connect together. And we want to deploy system. So right now, everything deploy as a part of the Kubernetes. And when you write the script, right now, since the tutorial that we show you, we want to abstract everything. So now we want to make use of the WebAssembly, so it don't need to deploy as a container image. But initially, we deploy a design system to work with the container-based application. So to deploying it and maintaining it, we're using the Knative, which is the Kubernetes-based serverless service. And then in the control pane, we will have the gateway that accept the multiple protocol. It support REST, gRPC, and then Seno and WebSocket. And then it connect to the router. Basically, it is the messaging infrastructure that you have before. So, and then the runtime is the WebAssembly that written on the last. So, and then you will have the TypeScript SDK, since you will develop this application using the TypeScript and then compile it as a WebAssembly. Cool. So yeah, you're gonna take care of this.
So hello again. I'm Topojit. So we're going to now jump into the hands-on demo. So we saw the pixel canvas demo at the beginning of the work tutorial. So we will now try to like deploy that demo, like the pixel canvas application, using our OAS framework. So to do that, we have created like the steps will be like, first we have created clusters for everyone to so that like where we have installed the OAS and like other necessary stuff, so that you can like go ahead and use the OAS directly. So to access the cluster, each participant has a unique participant ID. So let's say you can like 1, 2, or 3 like that. And so we have created, like I said, we have created an isolated Kubernetes cluster with OAS installed for each participant. And there, to access the OAS dashboard, which like each of you will have separate dashboards, you can use this URL, which is like p1.oas and then dot
So let's say I should use P1 and
yeah,
P2.
p2 and p3.
Maybe you use P1, I use P2.
Yeah,
You use P3.
yeah. So the URL is this one, and yeah, let me know when you have the access, like when you go to this URL. I supposed to have a QR code, but everyone has like separate links, right? So that's why I didn't was able to provide a QR code.
Use P2, which is the
You,
one.
you use P1, I use
Yeah, yeah.
P2, and you use P3.
Let me know when you have the access. So if you entered the URL correctly, you should see this dashboard, the console of OAS.
Does that mean we have to open all these three?
No, not just the p1.oas, which is the OAS console. This one, this one.
Is it?
Can you
I can reach P1.
you can reach p1?
Maybe that's the only one can be reached.
Huh?
There's only one agent. Please.
See from my it works from one side.
Okay,
I don't know
maybe
why.
because mine is a university laptop.
Yeah, that.
Firewall and everything.
Oh, yeah, yeah.
So this is P2, right?
Yes, yes, yes. Maybe you had already used P2, huh?
Can you put HTTP? It's 114. 114. Oh, that's my bad. It should be one.
114, I think there's a mistake there.
Oh, yeah, that's right. Yeah, the second, the example was misspelled. So this should be 114.
Oh, okay.
That's right.
Okay, I got it now.
It's working, right?
P4, yeah. So please, can you keep this? Please. Oh, I use P4, so your computer is P2.
Okay. So if you have so if you like entered the URL correctly, then you should like see this dashboard. And so this is the OAS console where you can like deploy the object as a service, like the classes and the packages and stuff. So now we have accessed the cluster for each of us. Now we're going to build the pixel canvas, like the application that we saw in the first part of the demo. We're going to build that application. To do that, can you go to, like we have the code in this GitHub repository. So you can click here or.
Just one question. This console, what we see is actually for that individual edge nodes. Isn't it?
It is the.
No, it's like you. So you have, let's say, that application, the Pixel Canvas application, we are going to deploy the whole application.
So which means
Okay,
the
let me
dashboard of
Yeah,
what?
you can go.
So what I'm seeing is this the software deployed on somehow that nodes called P1.
Yeah, it have a two environment set up
Okay.
there. So one is represent cloud and one is represent the edge.
Okay.
But I mean, two of them going to be like on the single machine, but there is a two virtual environment representing. So when you deploy it, you're going to see that there is a one of them deployed on the one environment, another one is on another web environment, and then both of them going to sync together so like as a edge and cloud synchronization.
So essentially now you want to see the entire thing as a developer. That was the earlier one was just a
Use
simple
case.
demo that
Yeah.
connected to an existing server.
So let's say you have an application that you want to, let's say, you used to use the function as a service to deploy your application, right? Deploy your function. Now you're gonna use how to use the object as a service or OAS framework to deploy the same application. So as an application, we're going to use that Pixel demo, like Pixel Canvas.
So what should we do?
can you go to this URL and like copy the code index.tx? So this is a GitHub repository, so you should, yeah,
Very
sure.
similar.
You can scan
You
it.
can just scan it.
And then I suppose we need to move my laptop.
Oh, I think this is a bit difficult.
If they have the presentation, I mean, they're supposed to have the presentation link somewhere. I'm not sure.
I get that fine. Maybe you can enlarge URL and URL.
What I did was sending the link to myself, so I.
Oh, okay.
Oh. Maybe show the full screen.
Huh? Oh, yeah. Yeah, can you?
I don't know why, but it's keep coming back. Oh.
Right.
Yeah. You got it?
Yeah.
Okay.
Oh.
Just keep that repo open because we are gonna need that in the like later in the demo as well. I think he got it, so
Okay.
that's fine.
Yeah. Just in case. Oh.
So this is the code. The index.tx is the code to the pixel canvas demo that we saw. So we need to copy that code from here. So you can see that in the GitHub you have this copy option on the top.
We go to index.ts.
Yeah. Go to the index.ts and
Then click copy.
yeah, click copy. And then if you so now we are going to go to the OS console and go to the artifact option. Yeah, click on the artifact option.
Can you show the real one?
Oh yeah. Let's say
I think it's okay, we could do that.
yeah.
Could you go to the artifact?
It's already there for a while.
Okay.
Yeah.
Okay, so
Okay.
we're all set. So
Yeah. So once you are in the artifact,
I think it's
oh my bad, you should go to the scripts, and then you should see a editor in the middle like this, and just paste the code there.
So they overwrite the existing one?
Oh yeah, just Control A and then paste the
Control A.
whole thing. Yeah. So put the code in the editor in the middle, and then you should see on the right there is a build artifact. So basically, we are going to, let's say, for the code we need to build the containers, right? Or build the web assembly. So we're going to do that first. So we are click build artifact, and it should take no more than 30 seconds to build to be completed.
So let me clarify one thing. So this compiling, even though it will right now we compile on the front end and then you're gonna send it to the back end, but it basically like right now everything is on the GitHub. So and building is like there is a code for this. So basically it can be run anywhere. It don't need to be like this, but we just build the front end to make everything easier for the audience.
Okay. So the build was successful.
Yeah.
Okay.
So when you have a successful content, you can go.
Yeah, you can continue.
So when you have a successful build, you can click on the artifact.
Yeah.
And then
And then-
you can see the one package is there.
So previously there was no package. Now we build one container or one web assembly, so we can see an artifact here. So now this is our, let's say, this is the artifact for the Pixel Canvas application. Now we're going to use it and deploy an object, deploy a class or object. So now we need to build the Pixel Canvas package. So to do that, we need to go to the package option.
Maybe you can get rid of that.
This one? Yeah. I don't know. It comes coming back.
Yeah, this one.
And then click on new package.
gonna be like form based.
Oh yeah, and then click on the JSON or YAML. And then we should like, we have the code in the same repository. You don't need to scan this. So this is the same. If you go to the same GitHub repository, you should see another file, pixelcanvas.yaml, which is the class.
Resources,
Oh yeah.
pixel canvas at the end.
YAML, yeah. That is the like class and class definition that will point to this artifact.
Copy and paste it here.
Yeah, copy and paste it in the, select the YAML first. So once you like, because this is a YAML version of the definition.
Mine has a code. Yeah, it's that YAML.
Okay, so, and then, yeah, then if you have like selected YAML and then pasted it, then click on apply. No, don't click apply. First, you need to change the, we need to, whenever we build a new WASM or new container, it gets a new artifact ID, right? So we need to update the class so that it points to the artifact that we build. So if you go to the, if you like, once you paste it in the JSON or YAML, you can click on the functions. After pasting it, click on the functions.
Yes.
So it has two functions. So we saw in the pixel canvas, we can draw, right? So that is one function. And when we draw something, after drawing, we can play the game of life. So game of life is another function. So this class has two functions. So now we have built the artifact, right? So we build the code with the two function in the same code. So we are going to like click like update the artifacts for the function or containers for the function as the artifact that we built. So click on the first function, and then in the WASM module URL, pick the there is only one option available that we built earlier. So select that.
So that's a bit more explanation.
Yeah.
So previously it's supposed to work on any URL that we provide to you. That is connect to the GitHub container registry. But that is like a few months ago, and then somehow like they changed the infrastructure or something. Now it doesn't work. So now the WASM module cannot pull from the GitHub registry anymore. So that's why we need to build it
Locally. Yeah.
Not local, but on the cloud.
Oh, yeah,
on
yeah.
our side.
Yeah.
So click apply.
And now then there is another function also, right? And then we need to pick the artifact for that one as well. That do the same thing for that one. Go to the WASM module
Second function,
Basically, pick the
artifact.
artifacts.
Yeah. For both of the function, not just one.
and then
There are two of them. I don't know exactly which one I created. Then doesn't matter which one to choose.
If you get, yes, it's the same.
But where are they from? Is that created by me or somebody?
Oh yeah. So
Or it's P1, so you created it before.
They both are from there. It's fine.
Yeah,
Okay.
that's fine.
Then the function two do the same.
Yes, just click up. Oh yeah, just click here.
Yeah, the same.
and then click apply.
Yes.
yeah, and then click apply.
Package created successfully.
You said it failed to create a package. There's a-
Oh, maybe
maybe
it's
already
P1.
it's
Created. So if it is, I think I
Why
tested.
can't they override the previous one?
I think the name is the same. That's why. If you change the name, it should work, right?
Oh yeah, but I think because he used P1, that's the one that you chose.
Oh yeah. So that is the one that I showed, like I tested with. So
If there is a error.
maybe you can delete the package and recreate it. That would work.
Doesn't matter. So this is but is this a good one or not?
Which one that you made?
No idea which one, because
Okay.
I saw that I create something with P1 there, but then where is that something with the P1? Yeah, which one do I take?
We remove everything. Just
Why remove everything?
because like just to make sure that everything works.
Oh, then I have to do everything.
I think it.
Fine, I do that.
Just make sure.
But then I need to create artifacts first,
Yeah.
because not this one, because you remove the
I
artifact.
think
Artifact will work. Artifact is the same. Artifact can stay there.
Artifact is still there.
Oh yeah.
Even these two are from me.
Yeah.
So
This one is fine.
this is what I created.
Yeah.
5, 2, 6.
Just deploy delete the old
Yeah.
package and deploy a new one. It should work.
Yeah.
We tried to simplify it as much as possible, but yeah,
I mean, previously we not
Yeah.
to like deploy the package.
yeah.
GitHub registry just changed it. I don't know what's going on from them.
And then are we done? Yes, so what next?
Yes. So okay.
Okay, we can. So now we have like deployed so we have created the package, build the package. Now you need to deploy it. So you should see an option to deploy if in the packages. So you can see the packages that you created right now, right? Pixel Canvas. Yeah.
Yeah, I can see that.
Can you refresh?
Where?
Yeah.
Click on
Here.
Deploy. So we have built we have saved the artifact there, and now we're going to deploy the package. So once you click on deploy, it's going to be created. The functions will be deployed.
click create.
Click deploy.
Yeah.
Yeah.
Click that.
Yeah.
And then you create.
And then mean TPS, availability, CPU.
Yeah. So
And then click create.
and then select. So we had two environments. So you can select both of them, I guess, OAS 1 and OAS 2. So you can think of it like one edge and one cloud. So two environments.
Maybe it was good to call it OES Edge, OES Cloud,
Yeah.
and then create.
Yeah, and then create.
Ending.
Yeah, so wait few seconds for the deployment to become running. It should become running. Reload the window, maybe.
Refresh.
Refresh, yeah.
Yeah, running.
Yeah, it's running.
Can you refresh? Oh yeah.
It's working, right?
Yes.
Okay. Now we have the pixel first. So let's just recap what we did. We had the application that we want to deploy as an object, as a service in our framework. So we built the containers first, build the artifact, and then we used that artifact to we had the package or the classes definition. So we pointed that artifact in the class definition, and then we built the package and deployed it as a class or as an object. Now the application should be running in the cluster. So basically what you are accessing is a Kubernetes cluster, and you are accessing it through the OAS framework and deploying the functions in the OAS in the Kubernetes or function as functions through the object as a service. So your application should be running right now. So we should be able to access the Pixel Canvas. So that Pixel Canvas had two things, right? One is front end that we saw here, and another is back end.
Edge and Cloud.
Yeah, that is backend is so we deployed the front end for you already, like OAS console and the Pixel Canvas front end was already deployed. So all you need to do is deploy the backend of the application. So what we did right now is deploying the backend. So now we are going to connect the front end to the backend. Front end is already there in the class in your cluster. So it should be if you have the same URL, just in place of OAS, replace it with Canvas.
So
Just-
create a new tab.
And just copy that URL and replace keep your ID and everything else same, just OAS with Canvas. CANVAS. So it should be p1.canvas, then dot blah blah blah, the whole thing.
Right.
So if you entered it correctly, you should see this portal. You can see it, right? Now, so this is the front end. This is the front end. Now we deployed the back end, right? So we need to connect this front end to the back end, and we are going to connect it. So it is deployed as an object, right? So all of the objects are exposed through the gateway. So whatever application that you want to deploy, you need to deploy it using our console, and then it will be exposed through the gateway. So you need to put the gateway URL in the gateway URL box. So copy the same thing again and just replace the canvas with gateway 1. You can put gateway 2 as well if you want, because you had two environments, right? OAS 1 and OAS 2.
So I have HTTP OAS 1 gateway.
It's GW1.
Which one?
Gateway.
Gateway 1.
It should be GW1. Can you copy it? Copy URL.
So just copy the URL, like a Canvas front-end URL, and in the gateway box, this is the last step, and you should be able to see the final product after this.
PW1.
For the rest, stay same. And
Yeah.
just a launch. Is that what you want to say?
You want just GW1. So for the gateway is GW1.
DW1.
GW1.
Oh, it's not gateway.
Okay, I got it.
GW1. GW1, yeah. So we have two gateway. You can connect with the one.
Remove the department.
And
okay.
Yeah.
so you should be able to see the following UI.
Yeah.
Then
And-
how do I know it's the edge nodes or?
So you have the option. So in the front end, you have the option to select the audience and the presenter. So if you select the audience, then you are gonna see the edge node, and you can select the grid position as well, right? 0001 based on the participant ID. And if you want to see the cloud, you should click presenter and click launch, and all the other things should stay the same. So whatever you draw in the edge thing should be synchronized in the cloud in the presenter node.
So I should open a new tab for cloud.
Yeah, you can do that. Just copy the URL and then
You can go. You can copy and print it. You can just yes.
You can type whatever grid if you want.
oh yeah, you can also select the grid if you go back.
But if I just type this.
Oh yeah, that will work as well. It's just
Then
that difference
they
thing.
don't.
You can type
Yeah.
like
What is the grid like? Do they have a way to check? Is that really more than the total grids?
Do you have?
What's your question?
So it's like you can if you put
If I put it, you see.
100 cross 100.
Yes, it's basically like a string, like key value mapping. So
So you can do
ideally,
anything. But
ideally, if we don't have a computation limitation, you can make like 1 million multiplied by 1 million. But because your browser cannot handle it, and maybe server cannot handle it as well. But can you go back?
so you can go back and select the presenter mode and then click launch, and then you should be able to see the presenter thing and this window as well. So if you draw something in the edge, it should be synchronized in your cloud as well.
But
And you can play the game of life as well.
I think if you go that, maybe gonna be.
Yeah. Okay. 64.
Oh, yeah, 64
is the
is
largest.
I think 64 is like really crazy amount already.
To me, this is just the size of the objects. It's actually not a separate. It's just a
it-
socket.
no,
It's just a way to connect to the postbook edge nodes. Doesn't
Yeah,
matter
yeah.
you have to have it. Why it has number limits then?
The problem is the browser, because to render this, the browser need to handle a lot of things. I think it's not handle. I think it's still loading. It probably take a bit of time. Oh yeah, it start.
That's
popping
test
up.
player experience scared me.
Yeah. Oh, because you click that button, it's gonna run the game offline like every
Yeah.
2 times every second. But you can see like it able to handle. So the server side should be fine.
Oh no, it's offline.
Yeah.
Oh,
I
it's all
think
live again.
can you refresh this? Yeah, it's loading.
Which do you know?
But
the
that's
conclusion?
totally loads on my browser.
Yeah.
That has nothing to do with the actual backend.
Yeah.
Imagine my browser.
I'm not sure if there is like a payload limit or something, because if you put a lot of number, when it load, it need to like compose the one payload, and if there is a payload limit, it can be broken. I'm not sure, but just try to like reasonable number. I think I tried like 32 by 32 is still working.
Okay, that's good. It just goes to other entries as well.
Yeah. So the game of life is completely like not just a single object. Like it kind of combine all of the objects together. Like you can imagine like you have
Oh,
the eight device that basically like observe something on the real world, right? And then you want to compose all the results together.
Yeah, do you wanna to the conclusion?
Oh,
Yeah.
Really?
Yeah, I think that's
Yeah. So,
yeah, because the mic is.
yeah. Thank you for like attending. So, in this tutorial, as you can see, like is the idea of this is like we want to streamline, make a framework that streamline the edge cloud deployment. So you can use the application and then like deploy anything that it should like, work on your machine. And then if you scale it up on the multiple edge, multiple cloud, it should still working. And in this example, I know that it not like go really deep. It not show the like how to write the code, and it not show like how to write the configuration. But because the whole thing is really complicated, and without this framework, it get even more complicated. You need to set up like you need to you need to pick the open source or maybe like product solution in the real world, and then you need to deploy them. You need to build up the server. You need to build up the edge server, and try to make the way to connecting them like really complicated. But in this tutorial, we simplify it. We provide you the template and then deploying it and show how it works. So, and I want to say thank you for everyone for attending. And everything is on the GitHub open source. It is open source. So we have a first repo. It is a HPC Lab OAS, which is really old. You can skip that. And then the real repo is on the OaaS-IoT. We have a several publication on this work. One major thing is IPDPS transaction on computer that published next previous year. We also have a ACM SOCC on the 2 years ago, and we also published the paper on this conference as well. I will present it on the Friday afternoon. Yeah, thank you very much.
Good.
Mhm.
Yeah. So, Wiz, can you show that the slide that tells about the objects? Do you remember that we had a use case? Not in this slide deck. In another set of slides, you had one that's showing like the inheritance of the image and labeled image. Do you remember what I'm talking?
Oh,
Camera with the camera.
It didn't have camera, but it was a coding like the YAML part.
oh, so yeah, because the whole thing is like getting really complicated. I know what you're talking about. I have it here.
Yeah, there you go. So I think this is very useful for people to understand.
So right now we not like use this exactly format, but the idea is pretty much the same. So as I mentioned before, we try to deploy the package as the class system. So and the class can be inherited. So like the concept that we have in the object-oriented programming. So we have the image, and then you can extend the feature of image. So in this image, you can see that you have a two function like resizing and detect object. And then you can see there is a image. In this case, like it's not image anymore. It means container image. So previously, you can put any container image that you want to deploy, and then it could be like the Docker Hub, or it could be GitHub registry URL, and put it here, and then you deploy it. The system will pull the image and running. And the beautiful thing about this, you can extend it. So you can add the like some like specific image. Let's say the label image that is the output of the detect object. So detect object can be just like process the image and then add the label, so it become a label object. And then we can write a extra function, something like analyze, and make it just consume the image that have a labels attend to it. So, and then you can see like we have the field that called QoS. So basically, if you use the servlet before, you will know that it really bad effort. So let's say that you have the workload of 100 requests per sec. It's going to scale it up to meet your requirement. But the problem is before meeting the 100 requests per second, it's gonna take some time, and a lot of applications cannot handle that. Like sometimes you have a spike. So because that, like we think that we should have like QoS defined. So you can see that we know that like the dropper know the best about their own application. So you can define it like, okay, it can be like 100 requests per second, or it can be like 50, like based on each function.
So the current version of the code does this with Python? Like this
Uh,
definition?
it still use a YAML, but it not this schema. So right now we try to shift toward WebAssembly because right now it like
Maybe you can explain the pixel canvas YAML. To go to the
oh yes, I actually
Click on the link.
uh where you put it. Okay, I think I know what it is. This one? No.
No, go down in the hands-on
Why is it laggy?
because it's web version. Here, click here. And then pixel.
Oh, okay. So
Yeah, this is a real example that we use, right? A class definition, package and class definition. Zoom in.
Yes. So in this example, we have one class that called Pixel Canvas. We have like several option. So this is something that we kind of like in the process of the development. So it's hard to describe, but we can focus on the state part. So right now, we don't need to like define like specifically what is the state is because right now it's basically like key value. So we can have a state as like dynamic. You can add it anytime. So we have a multiple consistent model. One is lead you write. Basically like weak consistency. It just guarantee that if you write something, you're gonna lead something that after the state of that happen, it's not gonna be the stall that you don't have a write anymore. And another one is strong consistency. So idea is we want to have really strong, which means that when you write something, you should not see the impact of the author writing. So basically, write should be serialized. And then we have a function binding. So basically, we have a multiple function. We have a pen. The name suggests really straightforward. It's just a pen. When you write something, you're gonna call this function from the front end to the back end. And
so
then
when you're drawing things,
yes,
you're calling this function.
yes.
Follows going to
And
this.
I think it's shifted toward write batch. So the idea is the same, but this one is a bit more efficient because it just write in the batch. So we have a get canvas that basically when you open the browser for the first time, you're gonna download everything. So the reason that we cannot like handle like really high number because I think there is a payload limit. So right now we encode every single pixel as a one key value data. So it is keep it on the string base. So you can imagine that like one pixel is represented by like RGB. So in the string format, so it at least like 8 bytes. So and then you have like 64 by 64, which is like really a lot. And each canvas it only have a 32 by 32 pixel. So you have like 4 million pixel to download.
It's like specific to the application. It's not something related to the framework, right?
Yeah. So and then we have a set metadata, which is just set the name, and then we have a clear and game apply step. So and then you can see that okay, this is called function binding. The reason that we separate this because we want to separate between the class definition and the real function implementation. So you can have like single function implementation that can accept any kind of code. So and then connect it to a single WebAssembly image, WebAssembly URL. So in the WebAssembly, right now the WebAssembly is really good in terms of like resource management. You can define the number of fuel. Like you can imagine like if you have like some kind of like infinite loop, your system gonna like crash and run forever. But in the WebAssembly, we can define number of fuel. I'm not sure like how exactly it works, But if you run out of fuel, it's going to crash your system and stop. So you
Is
don't.
it the number of times the VAS
Yeah.
can run?
Yeah. So right now I put it really high number, just to make it able to run. It 1 trillion. Yeah, 1 trillion. I remember that the default is 1 billion, but when I run the game offline with the 32 by 32, it's not enough. So I just like put it as a 1 trillion to make it be able to run a game offline without any problem. And then we have a deployment. So you can see like we have a target environment, which is the OS1, OS2. But ideally we can deploy like set any name like cloud and edge 1 and edge 2. So and this
Maybe
is
it was better cloud and edge was better because
Yeah.
people could better understand it.
Yeah.
And then the ODGM, what was that?
It is just a epic some
Yeah,
like kind of like
a bit lost.
how we deploy the class. So in the class we have using ODGM to be able to run like maintain the state and run the WebAssembly runtime. So the ODGM is full name is Object Data Grid Management Manager. Yeah, which is basically like we can have a multiple ODGM like across edge and cloud, and each of them connect together with the messaging infrastructure that we use the Seno. So all of them gonna connect together and then sync the data. And then if the function want to call to another function on the object, it just translate the function call into the RPC across edge and cloud seamlessly.
So basically here, like if we had all those functions, like for our application, we can see that we have multiple functions here, right? So if we, so all of these functions are like separate functions. So if we didn't have an object, then we need to like, we didn't have this class, then we need to, let's say, separately deploy this one, and then connect them all together for our, because one application is like, is formed of multiple functions. So if we didn't have this YAML, like have this structure, then we need to do that. That's how the usual function as a service works. And then we need to connect the state with these functions as well. Because when we can see that when we draw something, the state was saved. It was not going away. So we need to do that as well. So but for using this framework, you can like deploy all those functions together and they are getting connected like on the fly. And you don't need to like the developers don't need to go deep and like connect the state and connect the functions or establish the workflow. So it's just simplify the whole function as a like serverless computing or function as a service as a like with these class definitions.
Where is the state started?
Where
The state of the action.
where is store?
Yeah.
So,
Audit.
Right now we use the ODGM that we not really like go really like deep or like how should it be store. So right now we just keep it. We have two options. Write to the disk like local disk, which we can connect it to the persistent storage with the Kubernetes, or we can just keep it in memory. So, but just simplify your the answer to your question. So yeah, we just deploy and it keep it inside ODGM, and it write to the disk
there is using the same function or
to user.
because here is one address for each user.
Oh, okay. So right now the state is keep it as the key value format. So if you want to keep it separate, you just use the different key. And if you want to function to share the state, you can just use the same key and something like that. And this key value it is sorted by key. So basically you can do the prefixes. Like let's say you can have like one function with a specific prefix and multiple state, and then you can do the prefixes to see that okay, what is the state that you have in this function. I think it may be like too much detail, but yeah, there's a one feature.
About that, where the state starts.
The state start,
If you have
store,
like,
store or start.
you started.
Or start.
Started like
So when you open it, right? Do we have a P1 here? Okay, excuse me. I want to do something real quick. So in the oh
You want
After maybe you may want to stop recording.
oh what the- เพื่อทำโปรเจกต์ OSP1